Welcome to the deep dive. Okay, so when we talk about artificial intelligence, AI, our minds often jump straight to self-driving cars, right? Or maybe those chatbots that seem to write anything these days.
Yeah, the ones that can write you an essay or maybe even a poem. It's usually about convenience or maybe just the abstract future.
Exactly. But our sources today, they reveal something fascinating and I think much more profound. It's AI for a greener planet.
Hmm.
And it's truly remarkable how quickly this tech is actually being deployed. I mean, not just theoretically, but with real-world tangible impact.
Hmm.
It's directly addressing the urgent crisis of climate change.
And what's really compelling here is precisely that shift you mentioned.
Yeah.
AI is moving beyond just being this clever tool in a lab.
Right.
It's actually delivering concrete, measurable impact across all sorts of different sectors of climate action.
Okay.
It's really about making our existing global systems smarter, faster, and, demonstrably more efficient.
Which is huge.
It is, and this directly tackles some of the biggest, most stubborn challenges we face when trying to address climate change. Everything from how we generate power to how we predict and respond to, well, devastating natural disasters.
So our mission today for you listening is really to give you a clear, comprehensive picture of this rapidly evolving field.
Yeah, showcasing recent developments, mostly from around 2023 to 2025, that really highlight AI's significant positive footprint.
And that's exactly what the deep dive is all about. We know you're busy, you're curious, and look, you want to be well informed without drowning in just an ocean of data, right?
Absolutely, there's so much noise out there.
So we've basically taken a stack of sources, cutting edge research, recent articles, our own detailed notes, and we're going to try and extract the most important nuggets of knowledge and insight just for you.
Hmm.
Today's deep dive is into this topic that's not just critical, but actually surprisingly optimistic. It's how artificial intelligence is rapidly becoming this powerful, almost indispensable ally in the fight against climate change.
Yeah, optimistic is a good word for it, actually.
We'll unpack how AI is making a tangible difference across multiple fronts, from, say, optimizing renewable energy to predicting extreme weather, and even discovering entirely new green materials. It's really a story of innovation, efficiency, and maybe a real path forward. Okay, so let's start with energy. When we talk about shifting to clean energy, sources like solar and wind are fantastic, right? Truly game-changing.
Absolutely fundamental.
But they come with this inherent challenge, which is their variability. The sun doesn't always shine, the wind doesn't always blow.
Intermittency problem.
And this intermittency has long been a significant hurdle for grid operators. They need a constant, reliable flow of power.
You can't have the lights going out every time a cloud passes over.
Exactly.
Yeah.
So how exactly is AI tackling this challenge of variability? How is it making these crucial clean sources dependable enough to power our homes and cities consistently without blackouts or needing, costly fossil fuel backups all the time?
Yeah, that's the key question.
Our sources show AI is stepping in with some truly elegant and incredibly effective solutions.
It really is a fundamental transformation in how we manage our energy infrastructure. AI techniques are fundamentally changing how we approach integrating solar, wind, even hydropower.
Okay.
And it's not just the generation, it's the overall management of the entire grid.
How so?
Well, they're doing this by radically improving forecasting capabilities, like predicting supply. They're optimizing the use of energy storage, think big batteries, and even streamlining maintenance.
Predictive maintenance.
Exactly. All this makes renewables far more dispatchable, meaning grid operators can better control precisely when and how their power is delivered.
Right, so they can rely on it more.
Precisely. And it makes them significantly more grid-friendly, which is crucial for maintaining a stable, efficient, and resilient energy system. It helps them play nicely with all the other energy sources on the grid.
That makes perfect sense. If you can predict the supply much better, you can manage it much better. What does AI allow us to predict now that was, I don't know, simply impossible just a few years ago, especially with renewables?
It's genuinely revolutionary. Imagine being able to predict, with, remarkable accuracy, exactly how much solar and wind power will be generated hours or even days in advance.
That sounds like the holy grail for grid operators.
It kind of is. And it's not science fiction anymore. That's what AI is doing right now. It uses these advanced pattern recognition techniques, what we call machine learning models.
All right, what kind of models?
Well, Things like long short-term memory networks, or LSTMs, they're particularly good at processing sequences of data over time, so perfect for predicting fluctuating solar power, for example.
Okay.
And alongside LSTMs, you have models like random forest and support vector machines, SVMs. They're now, routinely deployed.
And what are they predicting?
Not just solar and wind output, but also electricity demand, with a precision that the traditional old-school statistical methods simply can't match.
And how much better are we talking?
Well, one comprehensive review we looked at specifically found that machine learning forecasting reduced wind and solar prediction error by approximately 8.5%.
8.5%. Okay, that sounds maybe not huge.
It might not sound huge, but think about what that means for a grid operator. A lower error in prediction translates directly to much, much higher confidence.
Right. They can trust the forecast more.
Exactly. And this enhanced accuracy, combined with improved overall grid management through AI, contributed to an approximate 15% improvement in overall grid efficiency.
Okay, 15% efficiency. That's significant.
It really is. And the illustrative impact here is profound. Better forecasts mean grid operators can schedule less spinning reserve.
Ah, the backup power.
Yeah, that costly backup power, usually from fossil fuels, that utilities keep on standby just in case renewable output suddenly dips unexpectedly.
So if they're more confident in the renewables.
They can rely less on those expensive and polluting backups, which leads to significant cost savings and, of course, cleaner air.
So, okay, once we can predict the power with this incredible accuracy, the next challenge is using it efficiently, right? Especially with all those massive battery storage systems coming online now. How is AI making sure we're squeezing every last electron out of them?
This is where the dynamic capabilities of AI really shine, particularly a technique called reinforcement learning, or RL.
Reinforcement learning. How does that work here?
Well, imagine an RL agent, basically, an AI program that learns through continuous trial and error, feedback, the optimal times to charge and discharge batteries.
Okay.
It considers everything: predictions of energy supply, predictions of demand, current electricity prices, the grid's immediate needs, always aiming to maximize efficiency and value.
So it's constantly learning and adjusting.
Constantly. And our sources show that one such RL agent achieved roughly 15% higher storage utilization compared to conventional rule-based controls.
15% more use out of the same battery. That's huge.
It's not just a marginal gain, yeah.
Yeah.
It means we're getting significantly more usable energy out of our expensive battery systems, maximizing their economic value and their environmental impact.
And it's not just batteries, right? It's the whole grid.
Right. Beyond storage, AI-based smart grid controls are, well, revolutionary. They can dynamically balance electricity supply and demand across the entire network in real time.
How does that help?
Well, this capability directly reduces something called curtailment.
Curtailment. That's when they just waste renewable energy.
Exactly. It's where excess renewable power is simply dumped or wasted because the grid can't handle the influx or there's no immediate demand for it. It's incredibly inefficient.
Seems crazy to waste clean energy.
It is. By integrating AI, cleaner energy becomes more consistently available, which displaces the need for costly and carbon-intensive backup fuels. And it ensures that clean energy doesn't go to waste. It's like having an incredibly intelligent conductor for the entire energy orchestra, making sure everything plays in perfect harmony.
That's a great analogy. And it's not just about what comes into the grid or how it's distributed, but you also mentioned keeping everything running smoothly. AI is even predicting when critical equipment might fail before it actually happens, like a wind turbine or a transformer. That sounds like a huge leap for reliability.
It absolutely is. This is where predictive maintenance, powered by AI, offers just immense value. It fundamentally changes how infrastructure is managed.
How does it do that?
Well, techniques like support vector machines, SVMs again, and neural networks are incredibly adept at analyzing these vast streams of sensor data coming from thousands of turbines, millions of solar panels, countless grid transformers.
Just unimaginable amounts of data.
Right. And they can detect these subtle patterns, anomalies, slight deviations from normal operating conditions that might signal a problem before a catastrophic fault or a breakdown occurs.
So it sees the warning signs humans might miss.
Exactly. For instance, SVM models can classify complex operational data as either normal or potentially pre-fault behavior. This allows for targeted intervention, like sending out a maintenance crew before an outage takes place.
Which avoids costly downtime.
Costly and disruptive downtime, yeah, which is a major benefit for utilities and, of course, for us as consumers. And by dramatically boosting the uptime of renewable infrastructure, it also means more clean energy is consistently available.
And better return on investment for the renewable projects themselves.
Absolutely. Improved uptime directly translates into a higher ROI for these expensive assets, making renewable energy projects even more economically attractive and competitive.
So if we sort of pull all these threads together, the smarter forecasting, the optimized storage, this predictive maintenance, what does this all really mean for the bottom line, and maybe even more critically, for our planet? These aren't just tiny incremental improvements, are they?
No, the real-world impact is truly substantial, both environmentally and economically. Let's look at a really concrete example that highlights the financial upside. Google's DeepMind.
DeepMind, yeah, famous AI lab.
Right. They leveraged a neural network trained on just vast amounts of weather forecasts and historical turbine data, and they developed models for 36-hour headwind power predictions.
Go.
Now, this wasn't just some academic exercise. It actually, quote, boosted the value of our wind energy by roughly 20% over their traditional operational methods.
20%, just from better predictions.
Imagine that, a fifth more value from the exact same wind farm. That 20% increase translates to millions in additional energy delivered to the grid.
Which means more clean power displacing fossil fuels.
Directly, exactly.
Yeah.
Furthermore, a modeling study we looked at reported that combining advanced machine learning optimization with a diverse mix of solar, wind, and hydro energy could cut co-Euro emissions by approximately 7,500 to 15,000 tons.
How does it cut the emissions?
Primarily by smoothing out that inherent variability of renewables and significantly reducing the need for those fossil fuel backups we talked about earlier.
Got it.
So these efficiency gains clearly imply an improved return on investment for the renewable projects. Less money spent on costly backup generation, higher utilization of the expensive renewable assets, and ultimately you get a more reliable, more profitable, and genuinely greener energy system. AI is truly making renewables both more dispatchable and fundamentally more grid-friendly, which really accelerates our clean energy transition.
Okay, so beyond optimizing our energy grid, which is already huge, it sounds like AI is tackling even larger, more complex systems like our planet's climate itself.
That's right, the really big picture.
Modeling weather and climate has always been incredibly difficult, right? Requiring massive supercomputers and these really intricate physics-based simulations. Is AI really changing the game here, or is it more of like a complementary tool for climate scientists?
Oh, it's changing the game dramatically in ways that were honestly hard to imagine just a few years ago. These cutting-edge neural models are now rivaling, and in some cases, actually surpassing traditional physics-based simulations
Surpassing them in what way?
in both speed and accuracy,
Wow.
which raises a really important question. What does this actually mean for our ability to understand, predict, and ultimately prepare for climate events, especially as they become more frequent and more intense?
Yeah, the potential impact is enormous.
Think about the lives that could be saved, the property that could be protected, just by having a few extra hours or even days of reliable warning.
That's a huge leap. One of the standout examples from our sources, the one that really caught my eye, was DeepMind's GraphCast. What makes this particular model so revolutionary in the world of weather prediction?
Yeah, GraphCast represents a true breakthrough. It's a perfect example of what these advanced AI models can do. It's built on something called a graph neural network.
Okay, graph neural network. What does that mean?
Think of it as an AI that's particularly good at understanding relationships between different points. In this case, the relationships across a global weather grid, how the weather in one place affects the weather somewhere else.
Gotcha.
And GraphCast was specifically trained on over 4 decades of this global reanalysis data known as ERA5.
ERA5, what's that?
Think of ERA5 as a meticulously reconstructed, physics-grade historical record of our planet's entire atmosphere. It's like a digital twin of all past weather, which helps the AI learn the incredibly complex dance of weather patterns over time.
Okay, so it learned from decades of real weather data.
Exactly. And what's astonishing about GraphCast is its efficiency and speed. It can produce a 10-day weather forecast at a pretty high resolution, about 28 kilometers,
No.
or 0.25 degrees in under a minute,
Under a minute for a 10-day forecast.
on a single tensor processing unit, or TPU, yeah, which is just vastly faster than conventional models. Those often take hours, sometimes even days, to run on massive supercomputers.
That's unbelievable.
And it's not just fast, it's accurate. GraphCast was shown to, quote, predict weather conditions up to 10 days in advance more accurately and much faster than the industry gold standard system.
Which is the European model, the ECMWF.
That's the one. And this includes its ability to accurately forecast critical events like storms, cyclones, heat extremes.
So the things we really need advance warning for.
Precisely. And its sheer speed is a game changer because it enables the generation of much larger ensembles of forecasts.
Ensembles, meaning multiple predictions.
Right. Instead of just one or two possible scenarios for, say, a hurricane's path, you can generate 50 or 100 slightly different forecasts very quickly. This gives you a much clearer, more reliable picture of the potential outcomes and their probabilities.
Which is vital for making good decisions under pressure.
Absolutely. That probabilistic approach is vital for robust decision-making, especially for emergency managers.
That level of foresight must be, well, yeah, a game changer for those emergency managers. It sounds like we're getting much earlier and more accurate warnings for the most severe weather events, which could genuinely be life-saving.
Indeed. It translates directly into critical lead time for communities in harm's way. And building on the success of GraphCast, DeepMind introduced another model, GenCast, in late 2024.
GenCast, what's different about that one?
This is an ensemble variant specifically designed to generate dozens of hurricane scenarios up to 15 days ahead.
15 days. Wow.
And the improvements are striking. GenCast, quote, performed up to 20% better than existing baselines, including the ECMWF's own ensemble model in terms of track accuracy.
20% better track accuracy. That means much more precise hurricane paths predicted further out.
Significantly more precise, giving communities crucial extra time to prepare and evacuate. And here's the kicker. GenCast produces these complex multi-scenario predictions in mere minutes.
Minutes again.
For example, a 15-day forecast takes approximately 8 minutes on one TPU. Contrast that with the hours required for standard physics-based models that need immense supercomputing resources.
It's a different world.
It really is. And early tests conducted with the U.S. National Hurricane Center confirmed that these AI forecasts are already providing valuable guidance on both hurricane track and intensity, which marks a significant improvement.
So they're actually using this now.
They are integrating it. DeepMind's new Weather Lab platform is now delivering 50 scenarios out to 15 days for tropical cyclones under a formal partnership with NOAA. It demonstrates the operational integration of these advanced AI capabilities directly into critical warning systems. It fundamentally changes how we prepare for the most dangerous storms.
So AI isn't just for short-term weather forecasting then. Can it help us understand and project long-term climate trends too? Things that span decades or even centuries? That seems much more complex.
Yes, it absolutely goes beyond daily weather. While the immediate impact on weather forecasting is dramatic, AI is also showing profound promise for long-term climate projections.
How does that work?
Well, consider another model, Neural GCM from Google Research. This is a machine learning-based climate model designed to learn the complex physics of our climate system directly from data.
Okay.
Its 1.4-degree ensemble forecasts outperform previous best models 95% of the time for those medium-range 5 to 15-day horizons. So it's strong there. But remarkably, Neural GCM also excelled in climate scale predictions.
Climate scale, like decades.
Yeah. For instance, its temperature projections for the period of 1980 to 2020 had an astonishingly low error of only about 0.25 degrees Celsius.
Quarter of a degree error over 40 years. That's incredible.
Compared to an error of about 0.75 degrees Celsius in conventional models. It demonstrates that these learned models can effectively capture both the fast-changing weather dynamics and the slower, long-term climate features.
So what's the potential there?
Potentially, this could enable much faster decadal forecast systems. These are vital for long-term planning and adaptation strategies, allowing cities and nations to better prepare for future climate scenarios years in advance.
Okay, but there must be caveats, right? Can we just replace the old models?
That's important context, yeah. While these are incredible advancements, experts still caution that AI models are only as good as the vast amounts of data they're trained on.
Garbage in, garbage out, basically.
Kind of. And they emphasize that these AI systems should complement, rather than completely replace, traditional physical models, especially when dealing with extremely rare or unprecedented events where historical data might be scarce or non-existent.
Right, things the AI hasn't seen before.
Exactly. However, the overall picture is undeniably clear. AI-powered forecasting has dramatically raised accuracy and speed across the board. It's providing earlier warnings of extreme events and significantly more lead time for critical disaster response.
So it's a paradigm shift.
It really is.
Yeah.
A paradigm shift in how we understand and react to our planet's changing climate, moving us from reactive measures towards more proactive preparation.
Okay, so with climate change, sadly leading to more frequent and intense extreme events, devastating wildfires, widespread flooding. Early warning systems are more crucial than ever before. How exactly is AI enhancing our ability to predict and prepare for these disasters? Can it really act as a shield against their worst impacts?
Yeah, AI-driven systems are increasingly being deployed for exactly that,
Yeah.
early warning and risk assessment, and they are demonstrating markedly better performance than traditional methods.
Oh, makes them better.
They allow for smarter, faster warnings primarily because they can spot complex, often very subtle patterns in vast data sets that signal impending danger, things humans might miss or only see too late.
Okay.
And maybe more importantly, they help us communicate these risks effectively and in a timely manner to communities, enabling that crucial preemptive action, which is really the key to saving lives and minimizing damage.
Let's talk about wildfires. They're becoming an annual scourge in so many parts of the world, often appearing suddenly and spreading with terrifying speed. Can AI really give us a significant head start in predicting and managing them, potentially preventing larger catastrophes?
Absolutely. The ability to predict fire likelihood, especially under rapidly changing conditions, is critical.
Hmm.
An international team, for example, developed a sophisticated machine learning model.
What does it do?
It ingests rapidly updated weather data, sometimes refreshed every 30 minutes, to predict the near-term likelihood of fires igniting.
That's very near term.
Very. And in rigorous tests using historical Australian data, this model achieved a remarkable, quote, 47% improvement in predicting critical pre-fire conditions compared to the standard forest fire danger index.
47% improvement. That's massive.
It's not just a number. It means the AI can flag those sudden weather shifts like a rapid drop in humidity or a sudden gust of wind that can swiftly ignite and spread fires.
Giving firefighters a heads up.
Yeah, exactly. Enabling firefighters and emergency services to take preemptive action. This could mean pre-positioning resources, issuing targeted evacuation orders much earlier, or even initiating controlled burns when conditions are safer.
Are there other AI wildfire tools?
Yeah, other projects are leveraging satellite and sensor data for real-time fire detection and spread forecasting. For instance, researchers at USC built an advanced AI model, a type of generative AI called a conditional Wasserstein-Jan.
Okay, that sounds complex.
It is, but basically it's designed specifically to predict fire spread under varying fuel and weather conditions, giving a better sense of where a fire might go.
Very useful for planning.
Hugely. Utilities are even deploying these advanced camera and sensor networks equipped with AI-powered smoke detectors for extremely early blaze alerts, catching fires when they're tiny.
Smart.
And IBM and NASA have also released a geospatial foundation model specifically for mapping wildfire scars and identifying risk factors from past data, helping us understand and mitigate future risks more effectively by learning from the past.
That's incredible. Okay, what about floods? They're often highly localized, incredibly destructive, and can develop with frightening speed. How is AI improving our ability to forecast those, especially in, say, urban areas?
AI is significantly enhancing what are called hydrological models, the tools used to predict water flow and levels.
How does AI help those?
It does it by analyzing vast, disparate data sets, things like rainfall radar information, river gauge measurements, detailed terrain maps. AI can process it all together.
Finding patterns in the combined data.
Precisely. For instance, recent major European floods saw their rainfall patterns predicted with greater accuracy by AI-enhanced models compared to traditional ones. And AI is particularly valuable for high-resolution urban flooding forecasts.
Why urban specifically?
Because in cities, even small changes in rainfall or drainage can have huge consequences on densely populated areas.
Yeah.
AI can handle that fine-grained detail. The ECMWF, the European Weather Center we mentioned.
Yeah.
They now run an advanced AI forecasting system that rapidly produces many ensemble scenarios, specifically for heavy rain and potential flooding events, giving a probabilistic view of flood risk.
So not just if it will flood, but how likely different levels of flooding are.
Exactly. Machine learning models can also downscale coarse resolution forecasts, the big picture forecasts, to highly localized basins. And they can incorporate new real-time data, like from cheap IoT rain gauges deployed in specific neighborhoods.
Making the warnings much more specific.
Right. Some startups are even leveraging deep learning on satellite imagery to map flood extent in real time as a flood is happening, providing incredibly detailed inundation maps that are invaluable for early evacuation planning and directing aid to exactly where it's needed most.
Okay, we touched on this earlier with DeepMind's GenCast, but it really does bear repeating. The improvements in hurricane and tropical cyclone forecasting, especially that increased lead time and accuracy, they're monumental, right? This really impacts people's ability to prepare and evacuate safely.
Indeed, the progress here is, I think, a real highlight of AI's direct life-saving impact. DeepMind's tropical cyclone model represents a monumental leap forward. It significantly improves both the track and the intensity forecasts for these devastating storms.
How much better are we talking?
Well, their deep learning model cut the 5-day track error by approximately 140 kilometers compared to the best physics-based ensemble models.
140 kilometers less uncertainty 5 days out. That's huge for coastal areas.
It's a massive reduction in uncertainty, yeah. Furthermore, it matched or even beat NOAA's own physics-based system on storm intensity prediction, which is notoriously difficult.
So better track and better intensity forecasts.
Right. This means that emergency managers are receiving earlier and far more precise advice, giving them crucial extra hours, sometimes even days, to make those critical life or death decisions.
And it's faster too, you said.
Crucially, yes. These forecasts, including multiple probabilistic scenarios, can now be provided in minutes instead of hours. This marks a major shift. For the first time, AI predictions are actually entering operational hurricane warning workflows.
So NOAA is using them in real time.
The National Hurricane Center is actively testing and integrating them in real time. This translates directly to save lives, vastly improved disaster preparedness, and ultimately greater community resilience in the face of these powerful natural events.
The ultimate goal, it seems, is not just predicting individual hazards like hurricanes or floods, but building a unified system, one that can anticipate and warn us about all kinds of interconnected threats. Is that actually feasible with AI? Can we create truly integrated multi-hazard early warning systems?
Yeah, that raises a really important question. Can we move towards truly integrated, holistic systems that account for cascading risks, where, say, a hurricane leads to flooding, which leads to power outages?
Right, the domino effect.
Exactly. And experts strongly advocate for using AI to build exactly that. Integrated early warning systems that combine meteorological models, hydrological models, and even socioeconomic models.
Socioeconomic, how does that fit in?
Well, knowing which populations are most vulnerable, where critical infrastructure is located, how people might react, that's crucial for effective warning and response.
Makes sense.
A recent perspective piece in Nature Communications specifically calls for deploying interconnected foundation models.
Foundation models, like
Yeah.
the big AI models for language.
Similar idea, but for Earth systems, geospatial impact mapping, and communication. Think of these as super smart, general-purpose AI brains trained on vast amounts of planetary data, which can then be adapted to many specific climate tasks, predicting floods, mapping wildfires, and crucially, they would communicate with each other.
Can you give an example of how that might work?
Sure. Imagine an AI pipeline. It ingests cutting-edge weather forecasts from a meteorological foundation model. Then it combines that with real-time satellite images from a geospatial foundation model, and maybe even demographic data,
Okay.
to forecast not just a flood, but the specific areas and populations most vulnerable to flood damage. Then it could broadcast tailored warnings via optimized messaging, using a communication foundation model, different messages for different communities.
Wow, that's truly integrated.
It is. Such complex systems could be trained on both sophisticated physical simulations and real-world event data, learning from both theory and reality. In practical terms, AI allows for both long-term, decadal early warning.
Like planning for sea level rise decades out.
Exactly. Where planners use probabilistic climate projections to identify vulnerable infrastructure decades in advance.
Yeah.
And it also allows for acute, real-time warnings for immediate threats. International bodies like the European Union and various UN agencies are actively exploring and investing in these comprehensive concepts, recognizing their immense potential for global resilience and, frankly, saving countless lives.
Okay, we've heard about these incredible results AI is delivering across so many critical areas: energy, climate modeling, disaster prediction. But for our listener who might not be an AI expert but is genuinely curious, what does this actually look like under the hood? What are the core AI algorithms, the vast data sources, and the underlying infrastructure that make all this possible?
Yeah, it's good to peek behind the curtain a bit. The toolkit is incredibly broad, spanning a variety of AI paradigms. And crucially, it requires massive, diverse data sets and extremely robust computational infrastructure. It's truly a convergence of cutting-edge technology from various fields of computer science. So at its core, much of this work relies on deep learning. You see convolutional neural networks, or CNNs, used extensively. They're great at processing satellite imagery for things like flood mapping and wildfire detection because they excel at recognizing patterns in visual data. kind of like how our own brains recognize faces or objects. Okay, CNNs for images. What else? Then you have recurrent neural networks, like LSTMs, long short-term memory networks, and GRUs, gated recurrent units. These are vital for predicting time series data, things that change over time, like fluctuating solar irradiance or electricity demand. They're designed to learn from sequences of information, remembering important details from the past.
Got it. Sequences over time.
And perhaps most revolutionary are graph neural networks, GNNs. We mentioned them with GraphCast. They're used to model complex global weather grids because they understand how different locations and their weather conditions are interconnected spatially.
Right, the relationships between places.
Exactly. And surprisingly, even transformers, which were originally developed for understanding human language, are being adapted to understand and predict complex climate data. It shows their incredible versatility in finding patterns in all sorts of data sets.
Transformers for climate. Interesting. Are there other types of AI involved?
Definitely. Beyond these individual models, ensembles and generative models play a huge role. AI ensembles, basically running many different models or variations of a model simultaneously, and then combining their outputs.
Like getting a second, third, fourth opinion.
Exactly. It significantly improves forecast reliability and reduces uncertainty. It's like asking many experts instead of just one. Some teams also utilize generative adversarial networks, GANs, or other variational models.
GNs. Those are the ones that create realistic images, right?
They can, yeah. But here, for instance, that USC wildfire spread model we mentioned, that's a conditional Wasserstein GAN. It can generate realistic simulations of fire propagation based on specific inputs, like fuel type and wind.
Ah, generating scenario.
Right. Similarly, the advanced AI hurricane models output tens of probabilistic tracks. They generate a richer, more nuanced view of potential scenarios than a single deterministic forecast, giving emergency planners a wider range of possibilities to prepare for.
And you mentioned reinforcement learning earlier for batteries.
Right. Finally, reinforcement learning, RL, and optimization algorithms are absolutely crucial for managing dynamic systems over time. RL is perfect for learning optimal battery dispatch policies under uncertainty, figuring out the best times to charge and discharge by essentially trying different strategies and learning from the outcomes, much like a human learns a new game.
Okay. And optimization.
Other algorithms, like genetic algorithms, are employed for optimization tasks. Things like precisely siting new wind turbines for maximal energy yield based on complex terrain and wind patterns. They help find the best spots across vast landscapes computationally.
Okay, so a whole toolbox of AI techniques. But it sounds like these models don't just need sophisticated math. They need an enormous amount of information to learn from, almost like a fire hose of data, right? Where does all that come from?
They absolutely do. Massive, diverse data sets are the fuel that powers these sophisticated models. Think of it like this. The more high-quality data an AI can see, the smarter it gets.
So what kind of data are we talking about?
Well, historical weather reanalyses, like that ERA5 dataset from the European Center we mentioned, that provides decades of physics-grade, high-resolution global atmospheric data for training. These are essentially meticulously reconstructed, consistent historical records of past weather and climate, allowing the AI to learn how our planet's systems have behaved over time.
Decades of history.
Yeah.
Okay, what about real-time data?
Then, real-time environmental inputs stream in continuously from a huge variety of sources. High-resolution satellite feeds for missions like Sentinel, MODIS, GOES. Ground-based radar systems tracking rainfall and storms. Extensive networks of IoT sensors deployed across the environment, collecting everything from temperature to soil moisture to river levels.
Wow. Satellites, radar, sensors.
And what's more, the scope of data is broadening significantly. We're now seeing social, economic, and even textual data being utilized.
Textual data. How?
For example, natural language processing, NLP, is applied to social media feeds during a disaster to gauge public risk perception. How are people reacting? What information do they need? Acoustic sensors equipped with AI are even being deployed in remote rainforests to detect the specific sound signatures of illegal logging.
They're listening for chainsaws.
No.
Amazing.
Providing crucial data for forest conservation efforts. It's really expanding.
This level of computational sophistication and all this data processing, it must require immense computing power and a very robust technical backbone, right? Are we talking about supercomputers in every climate lab now?
Without a doubt. High-performance compute is absolutely foundational. We're talking about the specialized hardware that can handle these massive calculations really quickly, particularly the use of cloud-based graphics processing units, GPUs, and tensor processing units, TPUs.
The chips that power gaming and AI.
Exactly. They're specialized hardware accelerators, originally designed for graphics or other tasks, but now essential for AI. Along with sophisticated machine learning frameworks like TensorFlow, JAX, and PyTorch, they enable these demanding workloads to run efficiently.
So big computing clusters are needed.
Leading companies and academic institutions leverage massive computing clusters and specialized hardware, often in the cloud. Furthermore, there's a strong push towards open-source platforms,
Yeah.
like NOAA's AI4 Climate Lab, which share models and datasets to foster collaboration and accelerate development across the globe.
Sharing the tools.
Right. Some initiatives are even aiming to build climate-specific AI foundation models, or digital twins of the Earth, like NVIDIA's Earth-2 framework and IBM's Climate Foundation model. This signals a clear move towards more integrated, powerful, and universally applicable systems for climate action, creating a kind of shared, ultra-smart brain for understanding our planet.
It sounds incredibly powerful, but are there other considerations beyond just raw power?
Oh, absolutely. It's not just about raw computational power. There are critical considerations for ensuring these AI systems are robust and trustworthy. There's a strong emphasis, for example, on developing hybrid physics AI systems.
Hybrid, meaning combining AI and traditional models.
Exactly. Combining the best of both worlds, the physical consistency and reliability of traditional models with the speed and pattern recognition capabilities of AI. Researchers are also prioritizing explainability and uncertainty quantification.
Explainability, knowing why the AI made a prediction.
Right. Ensuring that we can understand why models make certain predictions and how confident we should be in those outputs. This is absolutely crucial for trust and adoption, especially in high-stakes situations like disaster warnings. You need to trust the warning.
Makes sense.
And finally, AI ethics and robust data governance are critical.
Yeah.
Addressing issues like potential bias in the training data,
Yeah.
maybe the data underrepresents certain regions, and ensuring representativeness across diverse populations. These are active and essential research topics for responsible deployment of these powerful tools. It's about building AI that is not just powerful, but also fair and reliable for everyone.
Okay, this is clearly a game changer for how we approach climate challenges, but what's the bigger picture here? How are governments, international bodies, markets around the world responding to AI's immense potential in climate action? Is there like a coordinated global effort, or is it more piecemeal?
It's becoming more coordinated, definitely. Governments and international bodies are increasingly recognizing AI's pivotal role. The policy landscape is evolving pretty rapidly to harness AI's climate potential, while at the same time trying to mitigate its associated risks.
Risks like energy consumption or bias?
Exactly. And economically, the sector is seeing significant investment and demonstrating clear efficiency gains, which makes a strong business case for its adoption, not just an environmental one.
So is there a global effort underway to actually guide this integration of AI and climate action? It sounds like something that would really benefit from international collaboration.
There absolutely is, and it's gaining momentum. A significant step was taken back in June 2023 when the UN's technology mechanism launched the hashtag AI for Climate Action Initiative.
Okay, AI for climate action. What's its goal?
Its primary goal is to promote AI tools for both climate change mitigation, so reducing emissions and adaptation dealing with the impacts, with a particular focus on supporting developing countries, especially the least developed countries and small island developing states, which are often the most vulnerable to climate impacts, but may lack resources.
Right, ensuring equitable access.
Precisely. Following this, at the COP28 Climate Conference in December 2023, there was a formal endorsement of an AI and climate action program. This program mandates climate tech knowledge sharing and emphasizes AI capacity building in national climate plans. That's a crucial step towards widespread adoption.
So getting it into national strategies.
Exactly. Relatedly, the UN Environment Program and the ITU, the International Telecommunication Union, have convened a coalition for environmentally sustainable AI. It has over 100 partners, bringing together tech firms, researchers, government bodies from 37 countries.
A broad coalition.
Yeah. And a crucial emphasis from the UN Secretary General himself is that for AI to truly deliver net emissions reductions and realize its full climate benefits, it must run on renewable power and be seamlessly integrated into smart grids.
That's a vital point. The AI itself needs to be sustainable.
It highlights that critical need, yes. AI can't solve the climate problem if it becomes a huge energy hog itself.
Are individual nations also prioritizing this connection between AI and climate, Or is it mostly these international initiatives driving things?
Oh, individual nations are certainly aligning their AI and energy policies now, recognizing the strategic importance. For instance, the US and the UK have deepened their cooperation on AI-powered clean energy. They even signed a memorandum of understanding in 2024, specifically on AI risk and safety, which also touches on energy implications, signaling a joint approach.
Okay.
Policy analysts are noting that secure access to cutting-edge AI chips will significantly boost both forecast accuracy and renewables integration. And AI
Hmm.
optimization could potentially cut global data center energy consumption by around 40 terawatt hours per year.
40 terawatt hours. That's a massive saving just from smarter computing.
Huge. Countries like China and the European Union have national AI strategies that explicitly mention climate change or environmental applications as key areas for AI deployment. The EU's Emerging AI Act, finalized in 2024, is particularly notable
How so?
because it will require high-risk AI systems, which could include some climate-related applications, to assess their environmental impact. Though the specifics on exactly what sustainability metrics they'll use are still being developed.
Interesting. So regulation is starting to consider environmental impact.
It is. And many countries are also actively funding dedicated AI for environment research and pilot projects. Think of France's digital plan, which includes AI for climate, or India's national AI portal, which highlights applications in sustainable agriculture and disaster management. So it's definitely a multi-level effort, from global coordination down to national implementation.
With all this power and potential, there must be a growing conversation about responsible AI development, right? Especially considering its own resource footprint. Are there emerging standards or ethical guidelines being discussed seriously?
Yes, this is a critical area receiving significant attention, and it's being approached through various international and national dialogues. Over 190 countries have now adopted non-binding AI ethics or governance principles, and many of these touch upon environmental responsibility in some way.
Okay, non-binding principles. What about something more concrete?
Well, for example, France's national AI strategy specifically calls for the development of carbon-efficient algorithms and promotes open reporting of AI's energy footprint. That pushes for transparency and incentivizes efficiency within the AI sector itself.
Making AI developers think about energy use.
Exactly. NGOs and industry groups like Climate Change AI or the Center for AI and Digital Policy are actively advocating for mandatory life cycle emissions reporting for AI models, pushing for even greater transparency.
Like a nutrition label, but for AI carbon footprint.
Kind of, yeah. And at COP28, there was even discussion of an AI for good pledge, similar maybe to the Paris Pact for data centers. The idea is to push for climate-friendly AI operations, things like using green data centers powered by renewables, and establishing clear carbon budgets for AI model development and deployment.
Carbon budgets for AI models.
It,
That's specific.
it shows a growing awareness and commitment to ensuring that AI's benefits don't come at an unacceptable environmental cost. It emphasizes that AI itself must be part of the solution, not a new environmental problem.
So, okay, it's not just about environmental good. It sounds like there's a very strong economic case for investing in AI for climate action, too. What are the current trends in investment and the economic returns we're actually seeing?
Absolutely. The economic impact is substantial, making it an incredibly attractive proposition for investors and governments alike. As we discussed earlier, machine learning can boost the value of renewable energy output by around 20%,
Right, the DeepMind example.
and significantly raise energy storage efficiency by 15%. Even a modest, say 2% increase in solar cell efficiency may be achieved through AI-driven materials design, directly adds to the revenue generated per solar panel over its lifetime.
Small percentages add up over millions of panel.
Exactly. Grid operators can also defer investments in expensive fossil fuel generators and significantly reduce the costs associated with blackouts by using those highly accurate AI forecasts to prevent system failures. Energy analysts estimate that optimized data center AI workloads alone could reduce global electricity demand by tens of terawatt hours per year, leading to significant cost savings globally.
And is the money following this potential?
The investment trends certainly reflect this optimism. Global clean energy investment is surging. The IEA projected it to reach roughly $2 trillion in 2024.
$2 trillion. Wow.
Within this booming sector, AI is a particularly hot area. A PwC survey reported that AI-focused climate tech startups raised an astonishing $1 billion more in the first 3 quarters of 2024 than they did in all of 2023 combined.
So massive growth in investment just in AI for climate tech.
Huge acceleration. Even large corporate venture capitalists, including the big tech giants and even traditional oil majors, are backing a significant portion, maybe about 25%, of climate tech deals, especially in deep tech areas like advanced batteries and climate modeling, many of which are inherently AI-driven.
Even oil majors are investing.
They see the writing on the wall and the potential returns. Governments, too, are funding AI climate R&D as a high-impact investment strategy, recognizing that dual benefit of economic growth and climate action.
But is there a potential cost to this AI-powered green future? Particularly, what about the energy use required to train and run these incredibly complex AI models themselves?
Hmm.
This AI sustainability gap is a frequently discussed concern.
That's an important and very valid question that's actively being addressed by researchers and the industry. While AI offers immense benefits, deploying it does require upfront costs, computing power, data infrastructure, skilled people. And training large, sophisticated AI models can indeed be very energy intensive. There's a growing awareness of AI's own carbon footprint, sometimes called the AI sustainability gap. Estimates suggest that data centers, which house much of this AI compute, might consume around 3 to 4% of the world's power by 2030.
3 to 4% is not insignificant.
It's a figure that demands attention, absolutely. Experts are very clear on this point. For AI to truly realize net climate benefits, AI must run on sustainable energy.
So does it? Do the benefits outweigh the costs?
Well, most current analyses find that AI's operational savings and overall energy consumption achieved through those massive efficiency gains we've discussed across various sectors like the grid, industry, transport, far exceed the energy cost of running the models themselves.
Okay, so the net effect is positive overall.
Generally, yes. And this is particularly true as data centers are increasingly adopting renewable power sources to offset their own footprint, effectively working to close that sustainability gap.
Are there other challenges besides energy use?
Sure. Other challenges include data availability, which can be scarce or proprietary in many regions, limiting how well models can be trained or applied locally. And there's the need for local adaptation models trained in, say, Europe might not generalize perfectly to conditions in Southeast Asia without further calibration and local data. Quantifying the exact return on investment can also be complex when the primary benefits are avoided costs, like prevented damages from extreme weather events.
Harder to put a price tag on a disaster that didn't happen.
Exactly. But despite these challenges, the trend is unequivocally clear. Where pilot projects have been implemented, AI consistently yields a positive net economic return by significantly improving energy reliability and lowering operational expenses. It's proving its value both for the planet and the economy.
Okay, beyond these major areas
Right.
we've covered, energy optimization, climate modeling, disaster prediction, our sources point to some less publicized but frankly equally fascinating ways AI is shaping our sustainable future. What are some of these emerging or perhaps overlooked developments that you think our listeners should really know about?
Yeah, AI's role in climate action is broadening significantly, moving into areas that are maybe less obvious, but potentially incredibly impactful. It's truly accelerating fundamental scientific discovery. It's enabling more effective nature-based solutions, informing crucial financial and planning decisions,
Wow.
and even reshaping how we communicate about climate risk. It suggests its full impact is really only beginning to be seen. It's a testament to the sheer versatility of this technology.
This is where it gets really interesting for me. AI helping us find entirely new materials for green technology, almost like I don't know, a digital alchemist. That sounds like something straight out of science fiction.
It absolutely does, but it's very real. Machine learning is dramatically accelerating the search for and discovery of new materials that are essential for next-generation green technologies. Think about how long it used to take to develop, say, a new battery material through traditional lab work.
Years, decades sometimes.
Exactly. Trial and error. In 2024, researchers used AI-guided experimentation to find better materials for solar cells and batteries, foundational tech for our clean energy transition.
Can you give an example?
Sure. An international team focused on perovskite solar cells, a highly promising new type of solar technology, by training their machine learning model on just 101 test molecules out of 1 million potential candidates.
Just 101 samples.
Right. The AI suggested additional materials that, when incorporated, raised the cell efficiency from approximately 24% to a remarkable 26.2%.
That's a significant jump in efficiency from a tiny training set.
It illustrates that, quote, enormous amounts of time and resources can be saved by applying AI in materials R&D. It drastically shortens the discovery pipeline from years down to months, maybe even weeks.
Any other examples?
Yeah, similarly, a collaboration between Microsoft's Azure Quantum Platform and Pacific Northwest National Laboratory's AI capabilities. They computationally scanned tens of millions of potential compounds
Tens of millions.
and identified a novel battery electrolyte material that slashes lithium use by approximately 70%.
Reducing reliance on lithium, that's huge for battery sustainability.
It's massive.
Yeah.
Such breakthroughs, which historically would have taken decades of laborious lab work and countless experiments, were computationally found in mere hours. This opens up paths to cheaper, more sustainable energy hardware batteries, solar cells that previously seemed inaccessible or just too time-consuming to pursue. It fundamentally changes the pace of innovation in clean tech hardware.
So AI isn't just for engineered systems like power grids, but also for wild places, helping us manage and protect natural ecosystems. That's a fascinating application that probably doesn't get enough attention.
Yes, it's increasingly being used to manage and monitor nature-based carbon solutions, which are vital for both climate change mitigation and adaptation. We need those forests and wetlands.
How is AI helping there?
Well, for instance, sound recognition AI, remember the acoustic sensors, is being deployed in rainforests to detect the distinct sounds of chainsaws, signaling illegal logging activities in real time.
So park rangers get an instant alert.
Allows authorities to intervene much faster, potentially preventing irreparable damage. Drones equipped with advanced image recognition AI are mapping reforestation progress with unprecedented accuracy, allowing for better tracking and verification of carbon sequestration efforts and biodiversity recovery.
Verifying that carbon offsets are real, basically.
Exactly.
Yeah.
Which is crucial. Furthermore, large language models, the text-based AIs and computer vision techniques are mining vast amounts of ecological literature, scientific papers, field notes, extracting crucial data and insights to improve complex carbon cycle models, helping us understand how carbon actually moves through natural systems with greater precision.
Learning from decades of ecological research automatically.
Right. These applications are often less visible to the public, but they are absolutely crucial for verifying the integrity of carbon offset projects and ensuring that biodiversity co-benefits are realized, making conservation efforts far more effective and accountable.
Okay, how is AI impacting the financial and planning aspects of climate action? It seems like understanding and pricing climate risk would be a huge area for AI, as you touched on.
You're spot on. Novel climate services are rapidly emerging, often powered by AI, and they're reshaping how we approach economic resilience in the face of climate change.
Climate services, what does that mean?
Well, these AI-driven tools are helping cities plan critical adaptation strategies. For example, optimizing the placement and design of flood defenses based on those highly granular flood risk maps generated by AI forecasts, allowing them to build smarter, more resilient infrastructure.
Using AI to decide where to build the seawall.
Essentially, yes.
Uh-huh.
Making sure it provides the most protection for the cost. Similarly, insurance firms are leveraging AI to price extreme weather risk with greater precision, using machine learning forecasts to better understand potential liabilities and make more informed decisions about coverage and premiums.
So impacting insurance rates based on AI climate predictions.
Potentially, yes. An OECD report specifically notes that climate risk decision support tools utilizing AI are now a significant growth area. Although it also notes that the development of consistent standards and calibration methods for these tools is still an ongoing process. We need to make sure they're reliable.
Right.
But ultimately, this helps make investments more resilient and allows for better allocation of resources where they are most needed to protect against climate impacts.
And what about the human side of climate change? You mentioned communication, understanding risks, how populations might respond to extreme events. Can AI really help there too? That seems harder to model.
It is harder, but AI is indeed tackling these complex societal aspects, moving beyond just the physical systems to human behavior. Natural language models, for instance, are being applied to detect and flag climate misinformation across various online platforms,
Fighting fake news about climate change.
helping to ensure that the public receives accurate, science-based information, which is absolutely critical for informed decision-making. Beyond just detection, AI is also being used to improve risk communication itself, tailoring messages for different communities to ensure they are understood and, crucially, acted upon effectively during crises.
Making the warnings more effective.
Right. And AI-driven agent-based models are a particularly interesting development here.
Agent-based models.
They essentially simulate how entire populations, modeled as individual agents with certain behaviors, might respond to scenarios like heat waves or widespread crop failures.
Simulating society's reaction.
Kind of. It allows policymakers and emergency planners to test different public health campaigns or intervention strategies virtually, helping them design messages and actions that actually resonate with people and lead to better outcomes.
Fascinating.
These social AI applications, while rarely highlighted maybe before 2023, are gaining significant attention. Frameworks like FATES, for example, are explicitly designed to include psychological aspects in AI-powered early warning systems, recognizing that human behavior is a critical variable in disaster response. It ensures the warnings reach and motivate the people who need them most.
You mentioned the energy cost of AI earlier, which is a real concern. Is AI itself becoming more sustainable, or is that a separate challenge we need to solve independently?
That raises an important question, and the answer is yes. There's a significant and growing movement focused on making AI more sustainable and efficient in its own operations. It's not being ignored.
What does that look like?
Initiatives like the Frugal AI Challenge focus specifically on developing leaner, more energy-efficient AI models. This involves innovations in AI architectures, like using more efficient neural network designs that require fewer calculations. It involves implementing low-precision training methods that use less computational power but achieve similar results, and deploying on-device AI.
Running the AI on your phone instead of the cloud.
Exactly. Where processing happens directly on a sensor or a local device rather than in distant, energy-intensive data centers. This dramatically reduces the need to transmit and store massive amounts of data, saving energy.
Smart.
Furthermore, cutting-edge research into novel computing paradigms, like neuromorphic chips that mimic the human brain's amazing energy efficiency, and analog computing. These aim to drastically bring down the power consumption of all computations, including those used for climate AI.
So fundamentally new types of computer chips.
Potentially, yes. This is an often overlooked but absolutely crucial frontier. These synergies, AI helping sustainability and becoming more sustainable itself, suggest that the full net positive impact of AI on overall sustainability is only beginning to be truly understood and realized. It could become a really virtuous cycle. Hashtag tag outro.
Wow. What an incredible deep dive. You've just seen how artificial intelligence isn't just some futuristic concept, something off in the distant horizon. It's a powerful real-world tool making measurable impacts right now. It's touching everything from the optimization of our energy grid to predicting devastating storms with, frankly, unprecedented accuracy.
Yeah, the speed and accuracy gains are just staggering.
Discovering entirely new materials for green technology, and even helping us understand these complex human responses to climate challenges. It's truly a testament to human innovation and ingenuity, isn't it?
It really is. You've just gotten a comprehensive look into how technology is not just reacting to climate change, but actively shaping our climate future. It's providing a clearer, faster, and hopefully more informed path forward. The speed and scale of these developments are astounding, and they offer a genuine sense of optimism, I think, about our capacity to tackle these grand challenges.
Absolutely. And so we leave you with this final provocative thought to mull over. Given AI's rapid advancements and its dual nature, it's both a potential energy consumer, especially during that intensive training phase, and an immense efficiency provider that could drastically cut global emissions.
That tension is key.
What responsibility do we have as a society, maybe even as individuals, to ensure that AI development is always aligned with a truly sustainable planet? How do we balance its incredible power with its potential footprint and ensure it's always a force for good, not just for immediate gains, but really for generations to come?